Medication and microchips are being developed in space. Why? And why should we care? Because it might mean a cure for diseases and better computers. Low gravity and other conditions enable the development of much faster microchips and better medication for diseases like cancer. Does the future of medicine lie in space? Well, there's a lot more to research up there than 3D printing using moon dust, a trick that NASA astronauts performed in 2021. Carrying out experiments in space allows scientists to study and produce medication without gravity. These conditions could lead to results that couldn't be achieved on Earth. That means we could get more effective drugs in the future, and maybe even new ones for, as of now, incurable diseases. That's why US President Joe Biden set aside several $1 million for NASA to pursue cancer-related research on the ISS in 2024. A low-gravity environment can speed up the development and discovery of complex molecules used in medicines. Misbehaving proteins are the reason for many diseases. That's why scientists crystallize proteins to examine their complex structures. In space, this process is much easier than on Earth. Understanding a protein can give scientists a better insight into disease mechanisms. They can identify drug targets and optimize drug design. In the future, that could mean that we could get drugs that have fewer side effects, that are more effective or more resilient to temperatures. Beyond developing new formulas, it's also more effective to produce drugs in space, or at least parts of them. Molecules generated in space are more stable and can therefore also be larger and more complex. That's why several companies invest millions to enable the production of more potent substances in space and then transport them to Earth to manufacture the final product. Better computers thanks to low gravity? Low gravity research could also give us faster computers in the future. Semiconductors are the brains of most of our electronics in the form of microchips, but their development has stagnated in the last years. Their main components, typically silicon or germanium, simply have limits in what they can achieve. In space, there's a much bigger chance to optimize the structure of these elements. There's even the chance to generate completely new materials that could make computers faster. Some experts assume semiconductors made with materials generated in space could be up to 10 to 100 times more efficient. How is this supposed to work? In fact, none of this is really new. There have been experiments on the ISS for years, for example, run by academics, government agencies, and commercial customers alike. But access to the International Space Station is very limited, and interest is continuously growing. That's why big private space players like SpaceX and Blue Origin bet on commercial space labs that are floating in low Earth orbit. But there's also new startups like Varda Space Industries in the US or SpaceForge from the UK that tries to tap into that market. So researchers and developers could get the chance to come up with real innovations in the coming years, and private space enterprises might prove us wrong about being nothing more than expensive hobbies for the super rich. Do you think producing in space will lead to the next industrial revolution, or are you skeptical? Let us know.